Hi, PerspectaWeather.com meteorologist Paul Dorian here on Wednesday, August 29th. I wanted to provide an update to the beginnings of an El Nino out in the central part of the Pacific Ocean and its potential ramifications on the upcoming winter season in the eastern U.S. There are signs now for an expanding area of warmer than normal temperatures near and just north of the equator in the central part of the Pacific Ocean. Many computer forecast models have been hinting at an El Nino in the equatorial part of the Pacific Ocean later this summer or by the early part of the fall, and many of those same models maintain this El Nino into the winter season, and that often has major ramifications on the winter weather in the central and eastern part of the U.S. Now, not only is the intensity and the duration of an El Nino important, but we have found over the years that the specific location of those warmer than normal sea surface temperatures play quite a role in the temperature pattern during a winter season in the central and eastern U.S. There are really two types of El Ninos that we study now. One referred to as an eastern-based El Nino that really has its focus of the warmer than normal temperatures relative to normal just off the west coast of South Africa. And then there's a central-based El Nino, sometimes referred to as a Modoki El Nino, where the warmer waters relative to normal are concentrated in the central part of the Pacific Ocean as compared to the east near South America. And it appears as if the central-based El Nino will be the dominant type over the next several months as we go through the winter season. And that often leads to, or it certainly raises the prospects of a cold and snowy winter in much of the eastern half of the nation. Here's the latest look at the sea surface temperature anomalies, and I've circled a couple of areas of interest that again could have major ramifications on the winter weather in the central and eastern U.S. First of all, here's that area with above normal sea surface temperatures at or just north of the equator here in the central part of the Pacific. Notice the area nearer to South America's west coast still relatively below normal. And again, it looks like we have the beginnings of a Modoki type of El Nino, a central-based El Nino. Not only is that an important feature to monitor over the next couple of months, but what's going on here to the south of Alaska is important, and there's an area of warmer than normal waters that has been around during a couple of winter seasons this decade. In the middle part of the decade, for example, we had this persistent area of warmer than normal waters tucked in just south of the Alaskan coastline. And both of these, a central-based El Nino and a warmer than normal patch of water in the northern Pacific Ocean, can lead to cold air outbreaks into the eastern U.S. Basically, a ridge of high pressure forms along the west coast of Canada, maybe the west coast of the U.S., and that generally allows for the penetration from the northwest or the southeast of cold air outbreaks into the Midwest and eastern U.S., and that, of course, is a favorable factor for snow. Now, a central-based El Nino is a favorable factor for cold and snowy weather because, first of all, it adds water vapor into the southern branch of the jet stream, and the southern branch of the jet stream will bring storm track basically across the southern U.S. into the eastern U.S., maybe even up the east coast, and that, of course, is more favorable for snow than storms that go to the north and west of the I-95 corridor, for example. So added moisture, and it basically provides a lift, kind of adds energy into the southern branch of the jet stream. So this combination of a central-based El Nino and a North Pacific warm patch of water raises prospects for cold and snowy winter weather in the central and eastern U.S. Now, in many years, we've had strong El Ninos in the eastern part of the Pacific Ocean. For example, 1972, 73, and 10 years later, 82, 83, there were strong eastern-based El Ninos. And when you have a strong El Nino in this part of the Pacific Ocean, it tends to flood the eastern half of the nation with warmer than normal air. Doesn't mean you won't get snowstorms. In fact, The entire winter of 82, 83 was a warmer than normal winter, a strong eastern-based El Nino, and yet it featured one of the biggest snowstorms of all time in February of that year. The conditions just became perfect for a snowstorm around February 11th time frame in 1983. At the time, it was the biggest snowstorm ever in Philadelphia, only to be topped years later, the 1996 January storm. But again, a strong El Nino in the eastern part of the Pacific Ocean can certainly lead to warm air flooding the nation. But even in those winters, you can get good snowstorms once in a while. But again, right now it appears as if we're headed for a central-based El Nino and a warm patch of water south of the Alaskan coastline this upcoming winter. Both raise the prospects for cold and snowy winter weather in at least much of the eastern half of the nation. Well, let's take a look at the latest forecast for the strength of the El Nino in the central part of the Pacific Ocean. This is a series of dynamical and statistical type of computer forecast models going forward here. And this particular region right here represents the prediction by all of these models for the December, January, February time frame, the upcoming winter season. And on average, which is shown here by the green, they're predicting a moderate El Nino, anywhere from a weak to a moderate El Nino. A few cases stronger, but I don't think that will happen. But basically a weak to moderate El Nino in the December, January, February time frames predicted by many computer forecast models. Now, I'm not going all out right now, the end of August, and predicting a cold and snowy winter. I want to wait a couple of months for a couple of reasons. First of all, these models are not always accurate. Last year, 2, 3, 4, 5 months ahead of time, ahead of the summer season last year, they were predicting an El Nino that never really materialized, and that led to a more active tropical season in the Atlantic Basin. So I certainly want to wait and continue to monitor that warmer than normal water that is now forming over the central Pacific, to just make sure it's not a false start. But again, many computer forecast models have a weak to moderate El Nino for the upcoming winter season. Well, in terms of location of the El Nino, this is one specific model from the Japanese meteorological agency known as the JAMSTEC. And this is the forecast from this particular model, which is a good model. I've tracked it for years. For the December, January, February time frame here, it has the focus of the warmer than normal conditions out in the central part of the Pacific Ocean. Out here, basically a Modoki type of El Nino, a central-based El Nino for December, January, February. In addition, it maintains this warmer than normal water just south of the Alaskan coastline here. And again, that tends to form a ridge along the west coast of the U.S. and Canada. The flow of air then allows for cold air outbreaks from the northwest to the southeast, from Siberia or northern Canada into the upper part of the Midwest or the eastern U.S. So again, this is one specific model, the JAMSTEC, that has a central-based El Nino as well as the northern patch of warmer than normal waters for the upcoming winter season. Finally, let's wrap up by some findings from a relatively recent publication that focuses on El Nino's impact on the U.S. temperature and precipitation patterns during a winter season. These particular maps are for a central-based Modoki type of El Nino, and this is based on empirical observations. What typically results from a central-based El Nino, and you normally have higher heights than normal here in the western part of Canada. Let's get rid of that. It looks clearer here in the black here. And that, again, allows for the outbreaks of cold air masses from the northwest to the southeast into the upper Midwest, into the northeast U.S. And again, this is associated with a Modoki, a central-based type of El Nino, higher heights than normal across western Canada. The temperature, the color scheme here represents, again, temperatures associated with a central-based Modoki type of El Nino, and it's generally colder than normal across the southern and eastern U.S. and warmer than normal where that higher pressure sets up across western Canada. So again, this favors raises the prospects of a colder and snowier winter in much of the eastern half of the nation during the upcoming season. Basically, it results in a dipole type of a pattern here, where it's warmer and drier up across the northwest and colder and wetter and perhaps colder and snowier up down across the southeastern U.S. and all across the southern and eastern U.S. So the combination of what appears to be the development of a central-based Modoki type of El Nino, along with a patch of warm water just south of the Alaskan coastline, raises prospects of cold and snowy weather here this winter in the central and eastern U.S., and we will continue to monitor all of this. I'd like to wait until the latter part of October or early part of November to put out a final winter outlook, because first I'd like to see the snowpack as it builds up across places like Siberia, an all-important cold air source. The snowpack in October, for example, in Siberia or the northern part of Canada are typically quite important for predicting cold air outbreaks into the eastern U.S. Also, want to continue to monitor the solar activity. Low solar cycles, low solar activity tend to be correlated with frequent high-latitude blocking events, which again favor cold air outbreaks into the northeastern U.S., and very well looks like it'll be a low solar activity type of winter season. So the final winter outlook comes latter part of October, early part of November, but for right now there certainly are some signs for a potential cold and snowy winter in the central and eastern U.S. That's it for now. For PerspectaWeather.com, I'm meteorologist Paul Dorian.